Hello students, welcome to the third video of integrals, that is of chapter 7. So in this video we shall see some different forms of integrals, and these are these 6 forms that I have written here. We shall integrate this type of functions, that is dx by x square minus a square, then dx by a square minus x square, then dx by x square plus a square, dx by root over x square minus a square, dx by root over a square minus x square, and dx by root over x square plus x square. So we shall see how to integrate these type of functions. So these are the general functions that I have written here, and actually we shall treat these functions as some established formulas. So here we have 6. Okay, now actually for all of these 6 formulas we have separate proofs. Let me do one of this proof. So for example, if I take number 4, here I have dx by root over x square minus x square. So this is a particular type of integral. Okay, now how to get log of this? So in place of this, you can see that in the denominator we have root over x square minus a square, isn't it? So if I use the substitution method, what can I put in place of x to find the integral of this? Now our primary task will be to eliminate this denominator so that we can find the integration. Okay, so to eliminate the denominator, what we can do is that we can put x is equal to a sec theta. Now why x equal to a sec theta? We see that if we put x equal to a sec theta, so it will be what? X square will be a square sec square theta. So a square, if I take a square from both of these, so it will be sec square theta minus 1, and that will be equal to tan square theta. Square square will cancel, so we shall get tan theta, and ultimately we shall get sec x dx. Okay, so accordingly, let us see. So if we put x equal to a sec theta, therefore our dx will be, so differentiating it, we shall get a sec theta tan theta d theta. Fine. Alright. Therefore the integral will reduce to integration of dx. In place of dx we need to write a sec theta tan theta d theta divided by root over, in place of x square, what we need to write, a square sec square theta minus a square, and that will be equal to integration of a sec theta tan theta along with a d theta. So since it is a square, I can take the a square common and bring the a outside, and so inside the root we shall be remaining with sec square theta minus 1, and what is that? That will be root over tan square theta. Okay, so we do not have to write the same thing again and again, and that will be, if I cancel the root and the square, we shall get tan theta. Fine. Now I can cancel out the a and tan theta, so we shall be remaining with sec theta d theta. Okay, now in the previous video we have seen that the integration of sec theta d theta is what? It is equal to log mod sec theta plus tan theta with the integrating constant. Okay, now what is theta? What is our theta here? In place of what is our sec theta? Sec theta will be x by a, isn't it? So a will come down, so it will be x by a, plus what will be tan theta? Now to find the tan theta, we can see it here separately. We know that 1 plus tan square theta is equal to sec square theta, and therefore tan theta will be equal to root over sec square theta minus 1, isn't it? And what is our sec theta? It is actually x by a whole square. Sec square theta is x by a whole square. Okay, so in place of tan theta, what I can write is that root over x by a whole square minus 1 plus c. Fine. So we have reduced it, and then what we can get, log of, I can divide throughout by a, or I can take the 1 by a common, so it will be a here, x root over x square minus a square, okay, by taking the LCM, plus c, and this will be equal to what? By the formula of log of a by b is equal to log a minus log b, so it will be x plus root over x square minus a square minus log mod a plus c. Now since a is a constant, log mod a will also be a constant, and this c, let us call it a c1, okay. Now from this I can get log of x plus x square minus a square minus, now what about this? This log of mod a is a constant, this c1 is also a constant, so I can just write plus c, okay. So constant plus constant will be a constant. So thus we have got, or we have found this formula, that is integration of dx by root over x square minus x square is equal to log of x plus root over x square minus a square, and this is how we can find all the other, or we can deduce all these formulas. So these 6 formulas will play a major role in the chapter of integration and whatever problems you'll be getting later. So now let us go to exercise 7.4. Now the first question we have is integration of 3x squared divided by x to the power 6 plus 1 with respect to x. Now what to do? Here I can write this as 3x squared divided by, and this x to the power 6 I can write x cube by x cube to the power square to the power 2 plus 1 square. Now this denominator looks like what? Looks like this one, isn't it? X square plus a square, okay. Now let us do one thing, let us substitute this x cube, because here we have only x but here it is x cube, so let us substitute it. Let x cube be equal to t, therefore 3x squared dx will be equal to dt, fine. Now okay, here we have a dx, so this integral will reduce to what? In place of 3x squared dx I can write dt here, and in place of x cube square I can write t square plus 1, okay. Right, so okay, now this is in the form of dx by x square plus a square, where our a is equal to 1, isn't it? And that is equal to integration of 1 by a means 1 here, so you just put a square, 1 by 1 tan inverse x by a. What is our x? It is t by 1 plus integrating constant, and that is equal to tan inverse, in place of t just replace it by x cube plus c. So quite an easy problem. Now let us see, before going to the further problems, let us see a few forms of integrals. So the first form we have is when we get such type of problem, integration of dx by a square plus or ax square plus bx plus c. So this is one of the form. So if such a case arises, then what to do? In such a case, we shall manipulate this denominator and try to make it a complete square, or we shall use the completing square method and make this something like x minus a whole square plus b square in this form. We shall try to bring it in this form or minus form, and then we shall be using either of these formulas, either this or any of these formulas, okay. So this is one form. The second form we have is integration of dx by root over ax square plus bx plus c. Just the same thing, the quadratic equation is inside the root. So in this case, how to solve it? We shall similarly try using the completing square method. We shall try to form a two squares, or write this in terms of x square plus a square or x square minus a square, and then we shall directly use these formulas. So this is the second form. The third one we have is integration of px plus q divided by ax square plus bx plus c. So in this case, what to do? In this case, we shall write px plus q, this px plus q will be equal to a into d dx of this denominator, that is ax square plus bx plus c plus b, and then we shall equate the terms. Here we have equate the coefficients of x and coefficients of the constant, and the constant we shall equate the constants, okay, and then we shall find the values of a and b and proceed accordingly. Similarly, we have another form, that is number 4, integration of px plus q divided by root over ax square plus bx plus c. This is also exactly the same, only the thing is that it is under a square root. We shall follow the same method as that of form 3, okay. So once we do some problems, then you will be very clear with this. So now let us see question number 10. So in question number 10, here we have integration of root over x square plus twice x plus 2, okay, dx, integration of this. Now this is in the second form, that is integration of 1 by a square root over a square plus bx, ax square plus bx plus c, isn't it? So what to do? So here at first take out this quadratic equation, this is x square plus 2x plus 2, and this is equal to, I can write x square plus 2x plus 1 plus 1, isn't it? This 2 I have written 1 plus 1, and now what is this in the, it is in the form of x plus 1 whole square formula. This part falls in the this part is same as x plus 1 whole square, isn't it? Plus this 1 can be written as 1 square, okay. Now so once we have written it in this way, so I can reduce the integral to 1 by root over x plus 1 whole square plus 1 square, integration of this. Now what to do now? You can see that this integral looks like this particular integral, that is root over x square plus a square, okay, but the only difference is that here we have x and here we have x plus 1. So what to do? Reduce it. Let me show you. So put x plus 1 is equal to t. So if we have x plus 1 is equal to, then what about dx? Dx will be dt. So we shall be getting, here we have dt root over, in place of x plus 1 we shall be writing t square plus 1 square. Now one thing is to be noticed is that if such a case is there, that is in this part, if it is x plus 1, x plus 2 by 3, x plus 4 by 5, whatever, x plus a constant, then generally no need to substitute it, because dx and dt will be same. So whatever the value will be, it will be same for both the cases, okay. That means simply you can recognize that this is acting as the x, this x plus 1 is behaving as the x, okay. So once you have got this part, now using this formula, what we can write? We can write this is equal to log of mod t plus root over t square plus 1 square, that is 1 plus c. And what is that? It is root over log, in place of t I can write x plus 1 plus, here it will be x plus 1 whole square plus 1 plus c, and in the next line you can just break the square, so it will be x square plus 2x plus 1 plus 1 will be 2 plus c. So this is the answer, and this is how we find the integration of such forms, okay. Now let us do question number 14. In question number 14, what we have is integration of 1 by root over 8 plus thrice x minus x square, okay, along with the dx. So we need to integrate it with respect to x. So now what to do? This is also the previous form, that is the form 2 that I have shown, but the difference is that here it will come with we shall see that a different formula we are getting, not this. Okay, so what to do? At first you take this out, 8 plus thrice x minus x squared. Okay, now next take the minus 1 common or take the negative common, so we shall have x squared minus thrice x minus 8. Fine. Now try to make this a complete square. So this we can write x squared minus, since here the coefficient is 1, so I can write 2 into x, that is 2 into a plus b squared, isn't it? So I can write here a 3, and since I have written this 2 extra, so we have to write a 2. So this 3 by 2 will act as the b. Now for this we need to write 3 by 2 whole square. Fine. And since this 3 by 2 whole square is the extra thing in this term, so we shall subtract it again, so that our equation or our expression remains same, minus 8, this minus 8 here. So what are the extra things we have added and subtracted? We have added this, subtracted this, we have multiplied this, we have divided this, so everything is same as it is. Now this part looks like what? X minus 3 by 2 whole square. And what about this? If I take a negative common, I shall have 9 by 4 plus 8, isn't it? So this will give us minus of x minus 3 by 2 whole square minus 4, 8, 4, 32, so it will be 41, minus 41. And if I take the minus common, so it will be 41 by 4 minus x minus 3 by 2 whole square. Just remove the bracket. Okay. So we have seen that this integration can be written in terms of this. So the next line, let us see what we can write. Dx, so reducing the integration, in place of this we can write root over 41 by 2, we can write is root over 41 by 2, or in this place let me write once, root over 41 by 2 whole square minus x minus 3 by 2. Is it fine? Okay, so that square minus x minus 3 by 2 whole square. Now what does this look like? This looks like the formula, this one, isn't it? That is root over a square minus x square. Now one thing I have told you, that here the x, this is only x, but here it is x minus 3 by 2. Okay, but here we're integrating with respect to x only, not with respect to x minus 3 by 2. So we need to substitute it. But in general what we do is that for such kind of thing we can directly integrate it, because after substitution also the things will be same. Just we need to consider this x as x. Okay, so therefore after integrating it, our answer will be a sine inverse x by a. What is our x? It will be x minus 3 by 2 by a, and a is root over 41 by 2 plus c. Now if I manipulate it a bit, so that will be equal to sine inverse, this 2 will go up, so it will be twice x minus 3 by root over 41. So this. Now let us see question number 22. Here the question is integration of x plus 3 divided by x square minus twice x minus 5 with respect to x. So this form is of the form 3 that I have shown you. So how to do it? At first, when to write x plus 3, when to write it as a into d dx of x square minus twice x minus 5 plus b. Okay, so once you have written this, now let us see, if we differentiate it we shall get twice x minus 2. Fine, and that will be is equal to 2 into ax and minus 2a plus b. Okay, so now what is our next job? Equating the coefficients. So equating the coefficients of x on both sides, what we shall get? What is the coefficient of x here? Twice a, and coefficient of x is 1. So we shall have 1 is equal to twice a. And what about this? It will be 3 is equal to minus twice a plus b, because here coefficient of x is 0. So in both the cases this will be same. Now from here I can get a is equal to 1 by 2. And from here what I can write? B is equal to 3 plus 2 into 1 by 2. And that will be equal to 4. So you have got the values of a and b. Now, so since we have got the values of a and b, so if I take this one as equation 1, so what I can do is that integration of, in place of this I can write x plus 3 divided by x square minus twice x minus 5 dx. So in place of this, what I can write is that x plus 3 means what? Integration of a into, or in place of a, I can write 1 by 2 into twice x minus 2 plus what is b? B is 4. So divided by x square minus twice x minus 5. So our half of the work is done. Now what to do? Since it is a there are two parts, so I can write this by this, again this by this. So in the first part I can write half of twice x minus 2 dx divided by x square minus twice x minus 5 plus 4 integration of dx divided by x square minus twice x minus 5. Fine. So we are getting two integrals. So let us consider it is half of I1 plus 4 I2. Okay. Now for the I1 case, in the I1 case, what is our I1? Here I1 is equal to integration of twice x minus 2 dx x square minus twice x minus 5. Okay. Now what to do? Substitute it. Put x square minus twice x minus 5 is equal to t. Therefore twice x minus 2 dx will be equal to dt. So what I can write, our integration will, or our integral will reduce to dt by, in place of this I write t. And what is that? Integration of log integration of 1 by t is log of mod t, and that is equal to log of, in place of t, what is we can write? X square minus twice x minus 5 plus c. Fine. Or just name it as c1, because we shall get another c, so we shall name that as c2. Now I2 will be, what is our I2? 4 into integration of dx by x square minus twice x minus 5, and that will be equal to, sorry, not 4, because we have taken 4 into I2. So integration of dx by x square minus twice x plus 5, let us do it separately. X square minus twice x minus 5 is, it can be written as x square minus twice x plus 1 minus 6, the same thing. Now what is that? This is x minus 1 whole square minus 6. Fine. And this 6 can be written as root 6 whole square, the same thing. So in place of this I can write this, that is x minus 1 whole square minus root 6 whole square. Fine. Now what is that is equal to? You can see that this looks like this formula, that is x square minus a square. So what is that? 1 by twice a log mod x minus a. What is our x? It is x minus 1 minus a. Minus a means minus root 6, and x plus a, so x minus 1 plus root 6 plus c2. Fine. Okay, so let us keep it. So therefore this was our original integration, isn't it? And we have separated into two parts and we have got these two values. So therefore our original answer will be 1 by 2. What is our I1? We have got I1 is equal to this. So 1 by 2 log x square minus twice x minus 5 plus c1 plus 4 into 1 by twice a. So here a will be root 6. Root 6 log of x minus 1 minus root 6 divided by x minus 1 plus root 6 plus c2. Now since there are two c's, so I can just omit them and directly write a c. Hello. Now let us see the last problem, that is question number 25. Here we need to integrate dx by root over 9x minus 4x square. So it is a question of MCQ type and quite an important one. So what to do here? Concentrate on the denominator first. Whatever be the situation, at first see what is this. Okay, so here the denominator is 9x minus 4x square. So what I can write? I can take minus 4 common. So we shall be left with x square minus 9 by 4 x. Okay, now what can I do about this? So this will be minus 4 x square minus, I can write a 2 here and a 9 by 4 along with a 1 by 2 x. Fine. So this 2 will cancel each other and we shall get the 9 by 4 only, and that will be equal to, now this is our x square and this is our x. So this 9 into 1 and 4 into 2, that is 9 by 8 will act as the b of a plus b whole square formula, or sorry, a minus b whole square formula. So this will act as the b. Now since it is a b, we need to write a square, and now this term is extra. So I need to write 9 by 8 whole square minus 9 by 8 whole square. Now yeah, this is fine because we do not have any other constants. So up to this it will be okay. So this is called the completing the square method. And next what to do? This whole thing gives us the formula x minus 9 by 8 whole square minus 9 by 8 whole square. Okay, and that will be equal to, if I keep the 4 here, so if I take the minus inside, so we shall have 9 by 8 whole square minus x minus 9 by 8 whole square. Fine. Okay, so now what to do? This was our integration. Therefore our integration will reduce to integration of dx by, in place of this what I can write, here we have 4 and 9 by 8 whole square, put it under a square under the bracket, minus x minus 9 by 8 whole square. So in the next line I can take out the 2, so it will be 1 by 2 integration of dx by 9 by 8 whole square minus x minus 9 by 8 whole square. Now what does this look like? This looks like this formula, that is a square minus x square. Sorry, we have a root over also. So since there is a root over, so it will change. So it will be now sine inverse x by a. Fine. So this will be equal to 1 by 2 sine inverse, what is our x? It is x minus 9 by 8 divided by a. A is 9 by 8. Okay, so plus c. Now if you manipulate it, it will be 1 by 2 sine inverse, so 8 will go up there, 8x minus 9 by 9. Okay, yeah, so it matches with question option B. So I think option B will be the answer. Okay, so this is how we integrate various forms of integrals, and these are very important, and you need to memorize all these formulas. This will be very essential. Okay, so this will be the end of this video, and in the next video we shall come up with integration by partial fractions, and that is 7.5, another important chapter. So till then, practice all the problems properly, and integration will help you a lot in whatever problems you do, especially in physics and all. So that will be the end of the video. Thank you.